All right, since you guys, loud and clear, so class.
Yeah.
Yes. Okay, thank you. You guys are awesome. Not implying anyone in here that is not here is not awesome because they're not here. So yes, there's some shade right there. It did just get dark in here. All right, so find the rate of change in a biology experiment. In metabolic experiment, the mass M of glucose decreasing according to the function M of t, 4.5 minus 0.03 t squared. M is measured in grams. T is the time in hours. Find the reaction rate M prime. That's what that means. So M prime, so that means the derivative of M, T is my variable, at T equals 1H. So, given this, let's do that voodoo. Now, does 4.5 have a variable? There's no variable, right? So guess what happens if it has no variable? Let's go back a little bit before we hit that 4.5. Let's hit this one right here. What do I do with that t squared? What do I do with the 2?
By the exponent by the coefficient.
Multiply the exponent, which is 2, by the coefficient, right? So that's going to give me a negative 0.06. And now what do I do with my exponent? What do I do with the exponent?
Natural log.
What?
Oh, you said exponent, so I thought of e is way. My bad. What did we say?
What do I do with the exponent? Christian.
Move it down. Multiply it. Do you know it?
I don't know, I just asked Christian,
Oh.
so.
You're doing derivative. No.
N minus 1.
Yeah, that's why I'm actually asking Christian. But
No.
he's like back there, and I'm like, I'm not pointing at you,
Oh.
like Christian's right there. Because I did mention Christian's name when I said Christian.
My bad, you.
It's alright, okay. Say subtract 1. Subtract 1. So, this is why it's voodoo. It's weird, but it works every time. The exponent multiplies by the coefficient. And then I subtract 1 from the exponent, so that's just going to give me t. So I subtract it from the exponent, so I'm left with that. Now, what do you think happens if there's no variable?
It's 1.
No eating in here. I have an ant's problem. No eating in here.
No.
So, right here, there is no variable, right? What do you think is going to happen to that?
No. 0.
0. If there's no variable at all, it becomes 0. It just drops off. So no variable becomes 0. And I will show that reasoning here in a moment. Now, I have my derivative. Now I want to try and figure out what it is at 1 hour. So t is going to be equal to 1. So m prime of 1 is equal to negative 0.06 times 1. So m prime of 1 is negative 0.06. The rate that is changing. So after 1 hour, the glucose, the rate of glucose as it's decreasing, is going to be going down 0.06 grams per hour. So my rate of change, if you think about rate of change, it's always miles per hour, right? Distance over time. But this time we're not talking about distance, but we're talking about whatever units it is divided by time. That's what my rate of change is always going to be. So this is going to be, it's going down in grams per hour. Yeah, does that sound good? Ooh, wait. Let's go back to my voodoo. So if I do my voodoo, We did this one yesterday, right? So, exponent multiplies by the coefficient, which is out front, right? So my coefficient, the number out front is 1, isn't it? 2 times 1 is? So f prime of x is 2x. Alright, so let's look at another one. G of x is equal to 2x. My exponent here is 1, right? Okay. So 1 times 2, okay, so g prime of x is 2, and what do I do with the exponent? I subtract 1, right? Yeah? I subtract 1, so 1 minus 1 is 0, so that's x to the 0, but anything to the 0 power is 1. So as I go through there, and then if I have h of x is equal to 5, is there any x's here? Is there any x's? No x's. So since there's no x's, that means that this is going to refer to that it has a slope of 0. So if I'm thinking about this, I graph this h of x. This is my x. H of x. So if h of x is 5, that is a horizontal line right here. You guys agree with this? Yeah? Okay, so, and we said calculus is always what? It always refers to the derivative or the slope, right? So, given this, what's the slope of that line? 0. It's not going up and down at all, is it? So, since this is a constant, it's constantly this, that my slope is 0. Now, does this make sense why h prime of x is going to be 0? So any constant is just going to give me a derivative. Oh, that's a prime, sorry. H prime of x is equal to 0. Better? Yes? Too far, too far. There we go. Okay. Finding average velocity. Now, when I gave you the notes the other day, I said average velocity is what? You wrote it on your notes. I told you, I said, hey, average velocity means something special. There's a reason why I print off these notes and you write stuff on it. Anyone recall? What does the word average mean? If I give you two numbers and I say find the average, what would you do? Add them together and divide by 2, right? So the average is basically that. But it refers to the secant line. The secant line. So if I have a curve, you notice right here, I have a function right here. It is a parabola, and there's a rock falling. Anyway, so if it's a parabola like this, okay, if it's a parabola, the secant is going to be the average, okay, the average. So this is going to be an example of a secant line. By here and here. I have 2 points. Secant line is I have 2 points and I find the slope in between those 2 points. That's what a secant line is. All right, Michael Callahan, Pat Tillman Memorial Bridge spanning the Colorado River, opened in October 16, 2010, spans of 1,900 feet. Largest arch bridge in the Western Hemisphere, and its roadway is 900 feet above the Colorado River. If a rock falls from the roadway in that function, S, okay, S is my position, equals F of t is equal to 16t squared, gives the distance, S. That's always important to know that you're not staring at your phone and you're writing that your distance is what variable? S. It's almost like you're, come on, put the damn thing away so you can pay attention to me.
I just turned it on.
That's even worse, because I'm trying to teach and you're like, I'm already bored, I'm gonna go to my phone.
I'm listening.
No, you're not.
Yeah.
No, listen, Linda. No,
Oh,
keep it away. Did you hear me say, put the phone away?
I did. That's what
Did
I
you?
told
Oh,
my
is that a way? Because you're gonna get a message and you're gonna stare at it and it's totally.
No, because I'm not do not disturb.
Uh huh.
Yeah.
Mm hmm. So you can't just like away from
oh,
you?
goodness.
Okay, thank you.
Yeah.
Yes, thank you, goodness. Alright, anyway, so distance is my variable S when I'm actually talking about all this. Or another way that they like to refer to it is position. Where is it at? In feet. That the rock falls after t seconds for 0 to 7.458 seconds. Here, 7.458 seconds is the approximate time it takes for the rock to fall 890 feet to the river. Average velocity of the rock fall is, so we're gonna find this out. Let's write out all my information. Where's that? All right, there. Information, my function. My function was, what's it, 16 t squared, right?
Yeah.
Okay. And how high is it? 9 what? 960? 890. Wow, I suck at this. All right, a couple things that we're gonna find out. We have our time, which is starting out here. .58 or 8.5? 5.8, yes. Now, we have a couple things right here. Average, so we know that this is falling off a bridge, right? Okay, so at 0 seconds, how high is this up? It's what? Yes, 890. So I can write that as a coordinate. For 0 seconds, I get 890. This is t, and this is height. Or, yeah. Next one. According to this, 7.458 seconds. What's my height? 0, right? Because it's falling, it's going to hit 0. Yeah? So far? Okay, good. So, do my math. So it's basically my delta y over delta x, which is y2 minus y1 over x2 minus x1. So y2, 0 minus 890 over 7.458 minus 0. And then we could throw this in the handy dandy calculator and come up with my average is going to be right here. 119.335 feet per second. Yes.
Should be negative, right?
Yes, it should be negative. Why should it be negative?
Because it's taller.
Yes. So, there we go. So yes, it is falling. It should be a negative right there because it's going down. That's the average feet per second. Now, you guys ever jump off of anything before? There's this bridge. I grew up in Kingman. So if you ever go to Bullheads, there is a lake over there, and there's a huge dam. We used to jump off the bridge right before the dam, and it's probably like 120 feet down. But yeah, we're stupid. So yeah. Anyway, if you jump off a bridge, are you traveling 119 feet per second as soon as you jump off? No. Why? Gravity's pulling, right? But not yet, right? So it's increasing in speed as you fall. So this is the average from beginning to end. So if you think about that, when you finally hit the water, are you traveling that fast or faster? You're probably traveling faster, right? So that's where that comes from. So average is just in between the two speeds. Since I start off going 0 and at the end I'm going really fast, that's what the average is. It's still pretty fast. Yeah, and try not to belly flop because that really hurts. All right. That being said, I am going to stop right here. I'm going to pick this up again tomorrow. Not tomorrow. When do I see you again? Monday? Yes, Monday. All right, so we'll pick this up because today's short day. Yes, it is. Make sure you guys all like, share, and subscribe. Okay. Go to my merch store. I have some cool merch there. There is a discount on the hoodies because cold season is coming.